Symfinder is a toolchain built in order to automatically identify and visualize symmetries in systems written in Java. Symmetry and local symmetry have been recognized as a way to comprehend and create order in nature and human-made artifacts. They have also been studied in software and been identified in object-oriented design patterns where, in accordance with the symmetry definition, a part of their design remains unchanged, while another may change. This allows us to detect variation points and variants who respectively mark the unchanged and changeable parts in a design. More details about the principle of symmetry can be found in the research paper published at SPLC 2019, whose link can be found in the description of the video. The symfinder toolchain automates this detection and is made of three parts. First, scripts clone from the Git repositories the projects to analyze. Then, the symfinder engine uses a Neo4j graph database to store information on the source code and make use of labels to detect variation points. Finally, a JSON output is generated from the database and used in a D3.js visualization, needing only a web browser in order to be viewed. On the website's main page is a link to a summary of the obtained results presented in the paper, where you also have access to an online version of the obtained visualizations. Let's see an example of highly variable project. Java IWT is Java's original platform-dependent windowing, graphics, and user interface widget toolkit. In the visualization window, you can filter isolated nodes in order to keep only zones with a high density of symmetries. By staying clicked on the node of the visualization, you can isolate nodes of high density of symmetries. On this visualization, we can see 5 zones of high density. A high density of symmetries indicates us on the presence of variability implementations. Let's zoom on one of these zones. The important size of components node means that this class has an important number of methods overloaded, whereas the bright color of dialog indicates a large number of constructors overloads. We can filter the classes that we don't want to see anymore. After a filter has been applied, we can remove it, and the visualization will be back to its original state. If a project is less variable, fewer zones of high density or variability will appear. This is the case, for example, with Apache Maven. Maven is a build automation tool providing dependencies management for Java written projects. This visualization is generated from the core of Maven, and Maven uses plugins to manage the building of the projects. We would then need to include the plugins in the analysis to see the variability of the project. These were 2 examples of projects, and to complete this demonstration, we highly encourage you to explore our visualizations that are available online at the link in the description of the video. Symfinder is an open source software you can get on our GitHub repository, and you can reproduce our experiments easily as it is fully Dockerized. Technical requirements and full instructions are available in the README, as well as other details on the visualization. Symfinder is also available for you to try on your projects. If you do so, please tell us. We would really be interested by your observations and the results you obtained.